In this video, I'm going to show you how to use the sum and difference formulae for sine. So here's the sum formula. Sine of x plus y is equal to sine of x times cosine of y plus cosine of x times sine of y. And then we've also got the difference formula. Sine of x minus y is equal to sine of x times cosine of y minus cosine of x times sine of y. So why don't we start off with an example using the sum formula. Here we want to compute the value of sine of 105 degrees. Now 105 degrees isn't a special angle where we know the value of sine off the bat, but it is the sum of two special angles. It's the sum of 60 degrees plus 45 degrees. So that means that we can use the sum formula to compute it. So let's go ahead and write sine of 60 degrees plus 45 degrees, and then we'll express that using the sum formula. That's equal to sine of the first term, so sine of 60 degrees, then times cosine of the second term, so cosine of 45 degrees, and then plus, now we just switch the sine and the cosine, so cosine of the first term, cosine of 60 degrees, and then times sine of 45 degrees, and we can just go ahead and compute this because we know what sine and cosine are for 45 and 60 degrees. Sine of 60 degrees, well, that is just root 3 over 2. Cosine of 45 degrees is just root 2 over 2. And then cosine of 60 degrees, that's a half. And then sine of 45 degrees is just root 2 over 2. And let's go ahead and find out what this is. So root 3 times root 2, that's root 6. And then all over 2 times 2 is 4. And then plus 1 times root 2 is root 2. And then over 2 times 2, so over 4. So to sum this up, this is just root 6 plus root 2 over 4. And there we go. There is an expression that is equal to sine of 105 degrees. Great, let's move on. So if we want to use the difference formula to compute the value of sine 15 degrees, well, 15 degrees isn't a special angle, but it is the difference between these two special angles. 60 degrees minus 45 degrees will make 15 degrees. So we can just go ahead and compute sine of 60 degrees minus 45 degrees, and then we can write that in terms of sine and cosine of 60 and 45 degrees using this difference formula here. So let's go ahead and do that. So that's sine of x cosine of y, so sine of 60 degrees cosine of 45 degrees, just like before, but now we have a minus in between the two multiplied terms, and then we can go ahead and write cosine of the first term 60 degrees times sine of the next term 45 degrees. And then it's just a matter of simplifying. So it's going to be the same as here, but with a minus in between. It's going to be sine of 60 degrees root 3 over 2, cosine 45 degrees root 2 over 2, then minus cosine of 60 degrees is a half, sine of 45 degrees is root 2 over 2, equal to root 6 over 4 minus root 2 over 4, and just combine that, root 6 minus root 2 all over 4. And that's our result for sine of 15 degrees. Now, one way to remember these sum and difference formulae is that they both are very similar. They both have sine x cos y to start out with, and then it just flips around. Cos x sine y is the last term. The only difference here is that the sum formula has a sum of these two terms, and the difference formula has a difference of these two terms. In other words, sine keeps the same sign with regards to addition versus subtraction between the two terms. Alright, now here's another example. This time we have to calculate sine of 5 pi over 12, and this is in radians now. Unfortunately, 5 pi over 12 isn't one of our special angles in radians, but maybe we can express it as the sum or difference between two of the special angles. Why don't we start by writing down what are the special angles in radians? Well, special angles, that's just pi over 6, and then there's also pi over 4, and then there's also pi over 3. Now, to make it easier to see whether 5 pi over 12 is a sum or difference of two of these, why don't we express these all as fractions with the denominator 12 to match up the denominators. So pi over 6, just multiply by 2 on top and bottom, that's 2 pi over 12. Pi over 4, equivalent fraction, multiply by 3, so 3 pi over 12. And then pi over 3, multiply top and bottom by 4 to get 4 pi over 12. Now, can we write 5 pi as a sum or difference of 2 pi, 3 pi, and 4 pi? Well, yeah, look at that. That's 2 pi and 3 pi. If we add these two together, we'll get that. Okay, so we can tell that we're going to be using the sum formula here. We're going to be using sine of x plus y with these two special angles, 2 pi over 12 and 3 pi over 12. In other words, pi over 6 and pi over 4. So sine of 5 pi over 12 is equal to sine of 2 pi over 12 plus 3 pi over 12, which is equal to sine of pi over 6 plus pi over 4. And now this is what we're going to use with our sum formula here. Pi over 6 plus pi over 4. So let's just plug it in and work it out. So this then, that is equal to sine of the first. So sine of pi over 6 times cosine of the second. So cosine pi over 4. Then plus cosine of the first, pi over 6, times sine of the second, pi over 4. Let's just go ahead and evaluate. So sine of pi over 6, that's the smallest sine, so just a half. Then cosine of pi over 4 is just root 2 over 2. And then plus cosine of pi over 6, that is the biggest cosine, so root 3 over 2. And then times sine of pi over 4, so times root 2 over 2. And then we've got just, 1 times root 2, that's root 2. Then over 2 times 2 is 4. Then plus root 3 times root 2, so root 6. Over 2 times 2 is 4. So we've just got root 2 plus root 6 all over 4. And there we go. There we have it. There's our value of sine of 5 pi over 12. All right, so here is a final example. We want to calculate sine of the difference 30 degrees minus x. So we can tell right off the bat that we're going to want to use the difference formula here because there's a minus. So now we just need to remember what is the difference formula. Well, that's just sine of the first term times cosine of the second term, and then minus that flip-flopped. So sine of the first term, sine of 30 degrees, times cosine of the second term, so cosine of x, and then minus that flip-flop. So cosine of the first term, 30 degrees, times sine of the second term, x, and let's go ahead and simplify that. So sine of 30 degrees, that's just a half. So a half times cosine of x, and then minus cosine of 30 degrees, that's just root 3 over 2, and then that times sine of x. So altogether, that's just a half cosine x minus root 3 over 2 sine x. And there we go, we're done. That's our result. Now we know how to compute sine not only for special angles, but also for angles which are sums and differences of the special angles. In the future, we'll also see how to do this for other trig functions, like cosine and tangent.